Synchronize this with my YouTube as well. So if you can hear me, just give me a little thumbs up, or if you can't hear me, let me know in the chat, or let one of the folks who's in the chat let me know. This is a webinar around reliability in Kubernetes. We're going to talk through a few things today, such as what does good look like, and what are some of the challenges that large organizations with Kubernetes have. And so one of the things that I wanted to do first of all was to introduce who I am and why I think my background is relevant to this subject. I ran SRE practices at American Express for a few years, as well as at JP Morgan, and more recently a company called Civo, a cloud computing company. And now I'm working at Canonical, the makers of Ubuntu, to build the K8s distribution, micro K8s and charmed K8s. And so I've seen a lot of interesting patterns over the way people use Kubernetes, deploy workloads, and some of the challenges that arise when you're trying to monitor systems reliably, but also the challenges when integrating those systems back into things like ServiceNow, ticketing desks, and other parts of the organization that don't work so well. So I think that one of the key challenges that I want to uncover today is going to be around complexity. The second one is going to be around personas and the democratization of who can look at issues, who can resolve things in clusters. Because as we'll come to understand, it's actually not as easy as it seems the larger your business scales. In fact, there's an inverse relationship there. So aside from me just talking, there's some companion stuff that goes with this. I'm just going to switch over and you should be able to see my desktop now. Again, please ping me, scream from the hills if you can't see anything. If things are too small as well, chime in and I'll do my best to monitor the chat. In fact, I'll just do that now and start the chat controls as well. So I've got a resource here called Cloud Native Skunkworks GitOps Bootstrap. This is a sort of a repository that is based around what we're doing today. What this entails is a set of applications that install within Argo CD, which is a popular GitOps platform. I have no preference for any GitOps platform. I like being able to write things in Argo because it's easy, but there are many others. What's important though is that this is the reference point for which I'll be speaking around today. I'm going to take some time to talk a little bit about how we actually deal with stuff. I'm going to talk about how we can then make it better, and hopefully the police sirens going by will be able to then look at how this deploys optimally, how you can start to apply your reliability goals and improve upon that. Before I get into this website, this repository, and before I talk too much about this, I wanted to just step back a moment and look at what I was talking about in terms of this wider organization. So today we're going to look at how do we set up a high-level workload, monitor that workload, and effectively employ the right kind of targets, and what are the challenges around that. Before I do any of that, I just want to do a quick recap of what do common SREs look to do with workloads. So a workload being a pod or a service that's doing some sort of process, and what do they look to do to make sure that's reliable? How can somebody in their team say, hey Mary, John, is this a reliable service? Is it improved in reliability or decreased? So typically what SREs will do is they'll employ something called golden signals, and one of the popular top fives for that is reduce. So reduce is around rate, errors, duration, utilization with an English S, and saturation. And the theory is if you have monitors for each one of these 5 signals, you should have a good high-level understanding of what's going on in that service. And I think we all know that that's wishful thinking, but it does get us part way, right? You can tell a lot of stuff if you can figure out a lot of these signals. So if the utilization is capped out and the rate is exceeding that, then you probably know that service needs to be scaled out. So I've mentioned cats. Now, just before we go further, let's just have a quick look at cats and get to know what that is. I've listed all the tools I'm using out also in this repository. So if you see a few things you're not familiar with, check that out, and otherwise I'll be happy to help. Cats is our bank workload for today, right? So it's my cat picks generator that I have running. It's super crucial for my business. It's going to serve as a talking point for whatever. This could be your card processing platform. This could be a distributed set of microservices with a backend. It's not super important, What's more important is around the monitoring part of the conversation. And again, this is where I'm really excited to talk a bit more about what some of the innovation Komodor is bringing to the space and what are some of these challenges that we're looking to overcome. And that's actually why I was so excited to collaborate on this. So I did promise that we talk about the installation. And you can see that I've separated these things into various workloads. So I have a logging layer that I put in, which is Loki. I'm quite a big fan of Loki because Grafana have doubled down on having a scalable type of solution where if you have something running on micro-K8s, which I have a bias towards as a low footprint Kubernetes, you might want to run Loki locally. And then if you want to scale it up, you can run Loki distributed. The same with the components of Mir and some of the other project components in Thanos as well, I believe, which is an open source project as well. What I like about this is that Loki uses Promtail, and Promtail, in my opinion, is superior to FluentBit just because of the way that relabeling comes out of the box and some of the constructs being K8s native. I've also got Cert Manager in here because it's utility that I want to access my cluster from the web with, but also to pronunciate that you can also have problems at this point in the flow, right? You can deploy an application with an invalid certificate, and we need to understand what the implication of that is. The observability stack here, as you'll see in the website, all of these things are segmented. The observability stack, which is under templates application _ observability, is kubeprom stack, which is a very prominent open source project that contains Grafana and Prometheus with a bunch of CRDs. Mine's loading a little slowly right now. Could well be because I'm streaming it 20 megabits a second. We then have Trivy, which is a great little security scanner. I used what I quite like about Trivy is that if I go, I think it's scan results or vulnerability reports, I can sort of switch over and see what's going on in my cluster, right? So you can see there's some criticals. There's a critical on the CATS application, which is another story entirely for another webinar. And then of course I've got Komodor as an application, which I pass my key through to, and then I've got Bootstrap. So let me explain how this works. And for those of you who are familiar with Argo CD, I apologize, but this is a little recap. So this repository is sort of self-assembling. What happens is, when you have Argo CD, you can point it to a repository and it runs a Helm operation on that repository. So I've just combined that so that I can say, Argo CD, look at this repository and look at what's in the templates, which are other applications. So it kind of acts as a springboard. So if we go to our Argo CD, we can see that we've got our Komodor, we've got logging, we've got Nginx, etc. And also what's kind of fun with that is you can add additional objects inside of this repository. For example, if I provision Cert Manager and I want to also include a cluster issuer, it will inject the owner reference back to the Bootstrap. So I can see that the cluster issuer for Let's Encrypt is associated with the Bootstrap provider. This also gives provenance, and it allows you to do a kind of a concertina effect, like a big tent up and out and then back in. You can see what I've done here, and little note is I've got these broken hearts because I was provisioning my domain name just before this webinar. So I've got these little broken hearts because the certificates aren't completely provisioned, but what I can see is the provenance of the certificates all the way back up to the Bootstrap. So that's what we're dealing with here today. We've got Bootstrap that will deploy out CATS, Cert Manager, Komodor, Nginx, observability, and a bunch of other bits and pieces. And that's a nice place to start because you can give this a go. You can literally grab... Yep.
Sorry to interrupt, but we can't see your screen if you're trying to show anything. We can only see you.
Okay, let me have a look. That's a very, very good thing for me to remember to turn on. So how far did we get? Shall I recap?
Yes, please.
Okay.
Like 5 minutes.
I apologize, folks. Thank you. I do. Thank you. I was to be fair, I'm streaming on two platforms simultaneously, so I apologize. So, just to recap, I mentioned us having reduce, right? So this idea that SREs are looking for signals in workloads, figuring out how to kind of write ways of getting those out. And before we get to that point, I want to explain the platforms we're using. I mentioned that we've got everything boxed as a set of Argo CD applications. These applications are deployed out. And if you would like to, you can simply follow the guide here and deploy this on your own Kubernetes as you want. what's really nice as well is that in the root of this YAML, if you have a key for Komodor, it will install Komodor. If you don't, it won't install it. Equally, if you don't have a PagerDuty key installed, it won't install it. These aren't destructive, right? So it won't deploy something out that fails and breaks. It will just install the right applications to suit you. So assuming you have all that set up, then what I want to do is to talk through a few of the tactics and techniques that I've used that are actually really small and easy to do, but really help you out, right? So one of the things is to add annotations wherever you can, but also to make your life easier by any means possible. So because I didn't have the screen on the Zoom share here, I just want to go back to this recap of provenance is really important, and I've illustrated it in a couple of ways. You can see it both in the left screen under Argo, but also if you go to your ingress, you can see that we have an owner, a reference, in fact, on this file. And what's really nice about that is that it manages. In fact, I don't think I can see the status field without doing a wide. But what's nice about that is it will destroy it when the bootstrap gets pulled up. So it's really important that we have this kind of system to refresh our clusters and to almost like do a setup and tear down style kind of thing. I also like the fact, as I mentioned a moment ago, that by having the app of apps pattern, this means that the values for the app of apps can be set purely inside of the bootstrap. And this is a technique that we use quite often. So I have exposed these. I'm deleting these after my webinar, so I'm not too fussed if people see these. These are just keys. They're not. There's nothing super nefarious if someone were to look at these. But for example, the PagerDuty key or my Komodor key, in this kind of process, I can plug these into Argo directly. Now, if I'm using Vault HA or I'm using sealed secrets, you only have one place that you need to update your secrets, right? It's only in the bootstrap. This is really good, and we'll get on to talking about this a bit later on, but when you have federated teams, you can then start to deploy secrets out through applications without needing to know about it. So we've talked about the setup and the installation, and hopefully by now you've either understood kind of what we've got deployed, and again, I'll just refer to all these pods sitting here, or you understand kind of where we're trying to go with this. You can see as well, I've got an insecure URL here purely because I have newly provisioned my new domain, and you can see here that the domain load balancer, which is actually down here, is operating as an Nginx application, and that domain load balancer is awaiting a certificate from the DNS propagation. If you're not aware, when you buy a domain name, it's not instant that domain name associates with your IP address. There's a level of propagation that goes down through all the registrar services until eventually it propagates. And so therefore, Cert Manager has to wait for that propagation time before it can then actually validate that you are the owner of the domain name if you're doing a DNS-based check. You can also do other forms of check as well, but still, this takes a little bit of time. So I've explained the layout. We can see what's happening now. I want to talk a little bit more about the application workload, and I want to start to bring some other things to light. So if I look at my stateful set, and I'm very intentionally moving between various ways of viewing this. I have no personal preference whatsoever. And you'll see that I have cats. Now we go down to our volume claim template, right? So typically speaking, when you're on a cloud provider, one of the big challenges is that each cloud provider gives you their own set of opinions on what storage class naming conventions should be. So GKE, EKS, whether you're using Linode or any other system, in this case I'm using DigitalOcean, has its own opinion. So I can use XFS storage, I can use the default block storage. A big problem that you often see when you have product engineering teams deploying out CATS applications and whatnot is that they will get the storage name wrong, or they'll get any other number of parameters wrong, simply because they're running off a template and maybe they haven't templated that out. And so what I want to do is I want to show you like how can I change something, and then let's have a look at what kind of things I've got in place to pick up on that change. One other segue I'll make, and referring back to my document before we get down that rabbit hole, is I've only really explained this so far, right? I've explained this box, which is a K8s cluster running all these services. I've spoken a little about Komodor, which I'll come to in a moment, but I haven't really spoken about another component here, which is PagerDuty, which is the ITSM. PagerDuty, if you are familiar with it, is very much a deep-seated tool that's embedded in a lot of enterprise organizations, because it has very strong ties to some of the ticketing systems such as ServiceNow. And so it's great. However, there are a lot of challenges with PagerDuty. It doesn't give you that kind of granular information. And typically people will install the link from Prometheus to PagerDuty directly, but they won't really build custom queries, or rather custom messages. And so you get some really kind of unhelpful statements that come through this, right? So you'll see the set of labels that are firing, and we're lucky because this is one of the default alerting rules that has a little bit of text to it. However, when the team is building a service, such as K8s, they often won't write a Prometheus alert rule. And if they're lucky, they'll have an SRE who cares about this stuff and might write an alert rule, but often it will be falling back to the default rules that come with Prometheus. To have a quick look at those rules, you get a whole bunch when you install the observability system. In fact, I believe that it would be represented as PROM rules, which are Prometheus rules, and alerting rules, which are installed as CRs, but they're not really tailored to your application, right? I don't really understand what the optimal is. And we've got this idea of reduce, but it's not really telling me, are cats being served around the internet? Is everybody happy? And so, this is kind of one of the first challenges that I wanted to bring to life, is that using PagerDuty doesn't give you the full story. And it's a challenge because it often also doesn't give you any integration with the cluster that it's talking about, right? So it's a webhook, it's receiving data, but it doesn't know anything about the cluster. And so coming back to that thing I mentioned a few minutes ago about annotations is, I did a similar thing earlier on in Komodor with Argo, and what I did was I used an annotation to link these things together. Like, I haven't got time to jump around the internet, so I've got these little links, and I can just go back and forward between these dashboards. And what was really nice was that it just saves me time. And I think this is something that experience speaks of a little, is when you're dealing with large-scale systems, time is really important. Like, you have enough time spent, as I'll go on to explain, dealing with the bureaucratic side of things. If you can start skipping and linking things together, it really speeds stuff up. I've seen people put kube configs in the notes of PagerDuty. You wouldn't believe it, but they do that in an incident because it's the single source of truth for many people. Many organizations who pre-Slack hadn't embraced a sort of an incident response channel or a war room channel would use PagerDuty. And there are tons of problems, let alone security concerns, of doing stuff like that. Talking a little bit around a larger scale organization, what's one of the problems that comes to mind when you want to kind of fix an incident? Let's say that we have a challenge, right? Let's just go ahead and think about a challenge. So I mentioned that K8s might be deployed with a different storage class. Let's just go ahead and break this, right? So I'm just going to change my storage class and call it something that doesn't exist. K8s is a stateful set, so I'm going to delete the stateful set and reapply it. And we'll talk about why is that a problem in the meantime. So just give me a moment to make sure this is actually deleting. What I'll do is I'll do a terminate on the current sync, and I will go ahead and check that that's working. So let's terminate that. Yeah, there we go. Okay, it's deleting, great. And then it's being recreated by the bootstrap. So why is this a problem? Well, this is a problem because I might be managing 15 clusters. I might have 3 of those in production. However, if you've ever worked at a company with more than about 1,000 people, typically there are processes involved around getting to production. And if you don't have those, then you consider yourself very lucky, right? Production clusters tend to have a lot more scrutiny, especially when you're working in financial institutions. And they will typically have break glass protocols. A break glass protocol is when you have to request an audit-trailed special one-time access to that cluster. They will usually do this if they're sophisticated by generating you a service account token. If they're unsophisticated, it will be giving you a limited SSH access to the underlying machines of that prod cluster. If you can believe it, that's actually a thing. So if you imagine these nodes, right, being under my production cluster, you will often be granted an exemption where your break glass will say you have access to this box via this proxy, and therefore you can go and debug something. But already we're coming at the wrong layer, right? I'm coming at the node to debug something that's going on at the application level, and it's an extra set of steps that I haven't got time for to deal with in my life, right? Like, there's so much other stuff I need to be getting on with. So, when I start thinking about the future of where things are going, and I wanted to start showing you folks sort of why I think it's really interesting that we have folks like Komodor trying to solve these challenges, I just think it's super important to set the context of why are these problem spaces being explored, because they are real problems in large companies. They're real problems. So getting access to a production cluster, I've had a production incident where I think it was at least 2 hours, even with an emergency request. And to talk through how this actually works is you would typically open a ServiceNow ticket, right? So that ticket would be opened. That would then probably go through at least 1, if not 2, perhaps even 3 layers of escalation before that ticket would then get answered and you would then get a response. And so the opportunity to me is that when you have a platform that is effectively able to give you real-time information about the state of a cluster without having to jump into it and even modify that cluster or work with that cluster, I think that's super interesting. And so for me, there's a real interesting coalescence between GitOps and also this idea of SRE observability and automation, this remote troubleshooting. And so that's what I want to really get into in a moment. So before you get there, we've now connected our ticket to ServiceNow. We've now got our response. We've now jumped into a node on that cluster. I've now managed to get the kube config of that cluster temporarily. And at this point, I've got to figure out what was the error. I might have had an issue come from PagerDuty. For example, this is a Prometheus error, which was when the admission hook didn't trigger, and I think it was also after a job update. But getting to the point of this being useful and actually resolving could be getting close to hours, right? And so, whilst I just want to see ultimately why aren't cats working, right? Why isn't my cat's pod working? Until I can actually get there, there are quite a few steps. And so I think that it's a really interesting illustration that we can get there with something like Komodor. And so I'm going to come on to talk about this a little bit more now. I hope that I've given a good illustration of where some of the pain points are and why it's interesting to start to be able to think about this sort of stuff. So I got a couple of clusters plugged into this, and I just wanted to kind of go back before I sort of looked at why I found this interesting. Is I had a couple of clusters plugged into this over a while, and what was really interesting is I had my Raspberry Pi cluster, and I looked historically over the past few weeks, and it was quite cool because one of the things, and I've replicated it here a little bit, is what I could see is that I had a bunch of scan reports that were failing from Trivy, but they weren't failing. What was actually happening is I had criticals in my cluster, and I thought this was a really cool way of exemplifying that they had job runs that were actually failing on the vulnerability scan. So it was reminding me that I have to go back and check this out. I think it's really interesting because when we start to think about the personas, not just the access, that's when it's something that I think is really interesting as a bit of a game changer. I mentioned all of this stuff around, an SRE requesting access to try and figure out what's going on in a production cluster. That's just the SRE. That's just the SRE, let alone a SecOps engineer, right? If you've got those vulnerability reports that are failing, that's a whole different thing. And so when you suddenly think about, tooling that makes your life easier and you can start to build out sets of functionality, sets of behaviors in the UX that doesn't require you to jump into a cluster, then you are bringing people closer to solving problems. Now, I mentioned earlier on as well that one of the things I was really interested in was around this improvement in DX and this idea. And what you can see right now is, let's get to the next stage of our demo. So I mentioned that we have this whole problem with our persistent volume claim not binding because of our demo. And what's really cool to me is that you can see, again, we've got an issue here, and I can also then understand exactly with what's going on, right? I would have had to do the same thing, right? That same action in this example, in this world, would have taken me 3 to 6 hours, right? And if you're working at a company that's making millions of transactions a day, that's huge volumes that you're missing, because let's face it, everyone loves cats. And so I can quite simply see with Komodor that we've also got this failure. Another thing that's interesting, or at least is useful, that I've really enjoyed, is actually this idea of integration into Slack, because as I alluded to, companies wholesale, even large enterprises, are moving to Slack, and they're kind of standardizing on Slack. And so Prometheus has some really good Slack integrations. However, Prometheus, again, unless you build your own webhooks, doesn't take you to the cluster. So anything that helps to give you direct cluster information and integration really solves that for you. So what I want to do is I'm going to go back and say, hey, I figured out that cats aren't deploying. Perhaps you as a team shouldn't have pushed that issue, or should have pushed that PR into your repo. Obviously, I've simulated that because I'm using my parameters. So if I go back now, I remove that, and it's going to change the injection into cats. I'll see that when I delete my cats stateful set, cats are all good. So I'll just do that again, and we can go back to Komodor to have a bit more of a look at some of the features that I also end up using all the time. So if I go delete, in fact I have to terminate because we're in a mid-sync, and our cats will come back, and then all be good, we'll all be happy. As we can see, the PVC is mounted. Again, it's not always about things not starting. Sometimes things fail, right? And so I added a few little extras that we can play with here, right? So cats is on my main branch. Let's think about a developer trying to do something good, right? They're trying to do something helpful for the team, but it ends up not being so helpful, and it regresses the service. So in my YAML values for cats, I have a flag called failure, and failure can equal true, right? That failure actually causes the web server to start dropping requests. And so what will happen is we'll get an availability issue. So if I jump into cats, we will see that availability issue, and we will figure out exactly what's happened. So I like to think that these are pretty common use cases, right? These are things that actually happen all the time. And by saving ourselves the trouble of having to jump through 13 different hoops and to see things brought up, then I think that it's really a good step in the right direction to democratize, as I said earlier on, that access to investigation. It shouldn't just be the SRE who is figuring this stuff out. It should be a team sport, but building the tools to make that easy and to set those integrations up, absolutely. That's something that your SRE can help you out with. So if we go back to our Bootstrap, we'll see that at the top level, the parameters for Bootstrap are things like storage class, and that storage class gets passed through and overrides here. However, I want to simulate a direct commit, because why not? That's what people do, right? So we'll set failure on as true. We'll say this is, this is going to cause some problems. And we'll put that directly into main, right? Which is another golden rule that we want to try and avoid, typically in most environments. Just while that's all propagating throughout the system, and again, I might do a stateful set reboot just to speed this up so it doesn't roll out. When we think about configuration in general, right, there's a whole bunch of things that people tend to fixate on and find really difficult to understand. And I think that comes into two buckets. One is the configuration constructs within Kubernetes itself, and the other is trying to understand all the configuration of a particular application, right? And so when we have the ability to view it or discuss that configuration in a very simple to consume format, we start to think about that configuration in a new way. And specifically what I'm talking about here would be developers are expected to be able to inject environmental variables into pods. They're expected to be able to set configuration maps on those pods. They're expected to do X, Y, and Z, and all these things introduce permutations when they are then running that code on their clusters. So as much as possible, I do like to try and centralize and make that configuration idempotent. So one of these golden rules that they do kind of fixate on at these companies for good reason is that people shouldn't just be in clusters mucking around and changing things. And that's why I think the traction of GitOps combined with immutable clusters is really where we're going. And I think that that's something that you see a lot more of in the near future. So we've deployed out this change. I should imagine that we'll see a synchronization in a moment or two. In fact, I can see that the last sync was my service monitor. So I'll just apply that configuration change, and we can look at how that is read in Prometheus. We can look at how that's read in the kubectl output, and then we'll look at how that reads in Komodor, and we can evaluate which is easier to read, how do we feel about each one, and what is probably going to be easier to show to a product manager, right? And I think that one of the things that was interesting to me was this idea of, as I mentioned a moment ago, about changing things such as PVCs, such as images. because I can totally see there being a value for folks who are looking at your cadence and deployment speed or deployment frequency. And so there's this interesting new level of meta construct around this stuff. And do you remember a moment ago I clicked that job to run, right? I clicked that job to run for the vulnerability scan. So if I go back, I think it's because completed. If I go back to my vulnerability scan report, as I'm trying to measure this stuff over time, it becomes really useful for me to be able to try and lower my vulnerabilities, just like it does to look at my deployment cadence to make sure that I keep cats healthy, right? I don't want cats to suddenly have availability issues where something goes wrong. And so I think that that's super useful to be able to build up this historical picture. And what was kind of interesting as well is you can start looking at pod events, right? So if we go over, like, say, the past, 7 days or something, I think I had pod events. Oh yeah, it's okay. So I've got running here. I can look on a case-by-case basis of what's going on, right, and what's happened. And so, for example, when I was, in fact, that's right now, that's the crash loop back off, and that's come from our pod, and that's because I've put the flag set to failure inside that pod. And so, again, you get instant feedback. But what I also wanted to mention was that building up this long-term view is super useful, because when I think about, like, my Jira progress or my sprint board, I want to say, oh yeah, that was the day we deployed a bunch of stuff, or that was release 2.0, or those are the things that we were trying to release. And I think that correlation becomes even stronger when you start to get the single pane of glass from a kind of troubleshooting perspective. So if I update on that, and in fact, if I go back from the events to my service, let's go have a look at cats. Oh, not me. There we go. That's the one I want to look at. And you can see right now that I got this availability issue coming up in droves, right? And, I remember speaking to the folks here a while ago, and this is one of the things that a bunch of people who are writing Terraform and Ansible every day and IAC, and they're working in the shell, are like, why do you need this stuff in the UX? And I think the thing they don't kind of understand is that the personas of who are using this and who are kind of working on these issues and tickets aren't always seasoned, hardcore Kubernetes experts, right? For example, are the pods healthy? Like, it might sound like a no-brainer, but having playbooks is so important. In fact, the amount of time at Amex we spent writing playbooks and committing them into Git was non-trivial, right? So when you think about having the ability to do that, it's super important, and they found it, right? This was my secret sauce. So I added failure as a flag into Helm, and failure, if you look at failure, what does it do in my cats demo? Let's go deep dive into the code, which isn't very much of. You can see when bad value is introduced, we start returning a 500, right? We start returning a 500 on that service, and as you may or may not know, Kubernetes performs health checks. And so if we look at the health check for the cats service, which we could do just here because I'm in the repository, we can see that the liveliness probe is on that health endpoint, and so the liveliness probe will fail, and I will see that I have issues. I can see that we'll have issues within that, and that it's failed. And what's really cool is that if you integrate this as well, you can go back to Git, and of course I can see my log saying that Alex has done something stupid. He's introduced failure. So if we rewind the clock, we can take this out. I could have done this also through the bootstrap, as I said, but it was kind of fun to be able to show you what a developer might do, right? They might change something in the code, it breaks, we can now see there's an availability issue. Reverted, failure. And we'll push that back up. So I wanted to sort of take stock of what we talked about so far, and to just think about this diagram in the context of the next few years and where things are going. I mentioned that we're looking at immutable clusters becoming more of a thing. Ubuntu Core, for example, is an immutable operating system, and micro-K8s can be run as an immutable K8s more or less on top of that. And immutable by the sense of you start it with a configuration and you can't change that for configuration. Like we can make that happen, and your workload does whatever you want. that is a trend that is definitely going to only increase because we're reducing the amount of variables and moving parts. I think that if you don't go down that route and have immutability, then you'll certainly have some sort of remote management capability, such as a GitOps process that has a scheduler. And so these things really compound the problem of being able to debug that cluster dynamically. An SRE's job is going to get harder and harder. And I apologize, I didn't show Grafana, but if we just jump in, you can see that K8s is still rebooting. It's doing whatever it does. We go to Grafana, and we go to the load balancer, which I've got on. Again, it's just a random endpoint for now. Is it 8080? Does anyone know? Well, it's HTTP. Okay, it's just HTTP web. We jump into Grafana, and the point I'm trying to illustrate is that writing logql for Loki is a bit of a learning curve. It is awesome. It's powerful, but it's a DSL in itself. Also, when you want to look at metrics, right? So being able to write metrics queries can be complex with promql as well. They've done really awesome work recently to actually start giving you this stuff built in, but still there is a level of institutional knowledge and muscle memory there that needs to be built up. In terms of actually getting to the source of understanding what's going on, I find that, let's say we found that a pod has a pod stopped working, right? A pod stopped running. So, if we wrote a query along the lines of our containers running, or name containers that status is not equal to running, and we find our pod, then actually we have to jump back out into K9s or into kubectl anyway, right? Because we wouldn't have the information. Maybe we would have it if we ran Loki, but again, we'd have to cross-correlate between Loki and Prometheus at the same time. Many large companies are still using Splunk because of that very feature, being able to do metrics from logs. But ultimately, anything you can do to reduce that helps enormously. So let's go and see what's going on with K8s. Okay, so K8s, the stateful set, as you might imagine, is complaining. It's saying, hey, I don't want to roll out. So what I'll do is I will just delete K8s and I'll redeploy it. Stateful sets can be like that when there's a persistent volume claim attached on the pod, and the pod doesn't want to shut down because of the claim on it, and it won't release it, and so therefore the stateful set can end up hanging. Another thing that I want to do is to make sure that my storage is mounted, which it is. I can also check with my volume attachment. More general SRE kind of help than actually around this demo, but the volume attachments are a particularly useful way of making sure that the mounted volume is correctly attached to your pod. And so we have K8s, and they're all good again. And shortly, my availability will be updated when that's all working. And so you can see that, hey, the availability is working. There was no change specifically. However, there was a deployment event because I deleted the stateful set and redeployed it. And I kind of think it's cool because I can go through this timeline of seeing these are all the things that Alex did today, and this is all the work that he did. So if it were me, I would probably end up taking like a screenshot like this and being like, I don't get paid enough to deal with this, so go fix it. And that kind of exemplifies what I like about the visual element of things. It also reminds me of there are a few security tools that have really come to light recently. I obviously mentioned Trivy, but there's some other ones as well. And what I love about them is the visual element. And I swear, the older I get, the less that I have to tinker in the shell and write like kube control to JSON to pipe JQ to then modify something through Xargs, the better, right? Because I have to bear in mind that being an SRE these days is not about me being the end user, but I am kind of like the plumbing wizard that gets it through to the product engineering team, and often they will be the people on call. So one of the things I didn't do was I didn't tell you what we were going to learn, or rather I did, but I didn't show you the little notes that I wrote. So I hope today we've concluded who I am. Hope that you saw what we were digging into. We're looking at kind of a bunch of problems that SREs haven't had to deal with. We talked about how clusters are set up. We talked about this particular cluster, how I've put tools together. I didn't dig into things like service monitors with Prometheus. Go take a look at the repositories. The K8s repository has a service monitor in there. It plugs into Prometheus. Prometheus will fire an alert that goes into PagerDuty. These things happen as well. So if you're curious, please do check it out. I then talked also about diagnosing application workloads. The reality of a situation is that reduce will rarely ever give you the full picture. As we saw, a PVC mount error is not quick to come up. Like that will only show if you've got an alert on quantity of pods. So if I don't have an alert that specifies going from 5 to 6 pods, and that 6th pod doesn't come up because I've rolled a change perhaps on that stateful set, and it's taking over with a new set of storage classes, that won't really show up as an alert unless I've written an alert for that. And so there is a gap there, and that's where a lot of toil is spent with Prometheus. Again, with Loki, we're writing queries for that. These are both incredible tools, but there is energy that needs to be spent in the observability layer to get the workload layer to actually be accurately monitored. And so when I can come along and not have to do anything, it kind of makes my heart sing, because let's face it, being able to read from the K8s event stream, K8s is pretty smart, right? It can look at scheduling and orchestration, and if we can combine that with this level of audit trail and also then remote debugging, I think one of the things I didn't mention is that I can do this kind of deal. So I can do sort of scaling events, I can do restarts and all sorts. If you're not in a GitOps paradigm, then we're really laughing, because then developers are enabled to be able to sort stuff out for themselves. Looking further, I put Komodor in brackets because, these folks have a place in my heart, because I think that the key challenge to engineers is going to be complexity. And I think, as I said earlier on, it's going to be that your time is in shorter and shorter and shorter supply. Whether you're having to diagnose something that's relatively trivial or complex before you even get there will be the bar to entry. Anecdotally, again, ServiceNow and whatever your ticketing system is just an example, but it can take forever to be able to get access to even look at the problems. Having hosted solutions or having solutions that are orthogonal to the cluster are awesome. Remember that my cluster is cluster in a box. Enterprises don't really operate like this. The observability is kind of usually over here, and you'll have a forwarding logger or a forwarding Prometheus remote write, or a scraper. However, the plumbing and the concepts remain the same. And so if you have taken anything away from this today, I would like it to be kind of evaluate your own SRE practices. I've not really spoken much around SLAs, around more of the SLO management side of things, more kind of the practicalities of troubleshooting and diagnostics. But challenge yourself. Think, like, where do I actually spend most of my time? Is it doing SSH shuttle? Am I doing double bastion jumps? Am I doing kubectl from some remote machine just to figure out the log entry? Or am I spending a lot of time in Splunk building custom queries? I'd be really interested to know, because I think that when you look at stuff like Komodor and you look at what they're doing in terms of bringing all of this quite deep-seated complexity to the surface, it's extremely exciting to think what you can do with it when you start to get more people from your team involved who have become responsible. Like, okay, you built the thing, you built the cats thing, this is your page, you go manage it, right? You're your own SRE, leave me alone, I've got other stuff to do. So I hope that was enjoyable. I hope I didn't sound too cantankerous as well. I'm really not. And if there are any questions, I guess please give me a shout. I'm going to switch back to showing my face, and we can talk. If that sounds good. Udi, are you still there with me?
Absolutely.
Awesome. Did that all make sense to you first, Udi? As somebody in the space, you tell me, did that make sense to you?
Well, yeah, absolutely. I think one of the things you touched upon is that the work with SREs is only getting more and more complex as time goes on, and more organizations migrate more and more workloads to Kubernetes, and then they have to onboard new developers. And I also love how you touched upon the, developers sometimes break things, not on purpose. They want to build great features, they want to build great apps, and they try to do it. And sometimes they break things, and then it's the SRE's job to handle it. And they, what do you think? If you had a tool like Komodor, would you want to give it to your developers? Would you like for them to have the ability to troubleshoot on their own, or is it something that you want to keep within the SRE team?
It's a really good question. I think it actually comes down to the economics of scale and hiring and all the really boring stuff. SREs are expensive to hire. They're also hard to independently geolocate. And so putting SREs on call for product engineering level workloads. And what I mean with product engineering is I mean people who are building products that your company makes money from, right? Like the credit card scanner or the awesome Cats app. So putting SREs on call for those teams is expensive. And so typically companies will harmonize around SREs being kind of platform SREs, right? And so I would prefer to give this to my product engineers, right? I'd say, look, this is your service, this is your Komodor page, this is where you can start to say, look, restart services, diagnose. They become their own L1. I think that's really interesting because they're L1, but they also understand the intention of the product. To give you an example, when I worked at, I think at like JPMC, you have a whole bunch of L1 support folks. They understand what the runbooks are, but they don't really understand what the product is trying to do, right? They don't understand operational tolerances in the sense of like, this is how it should look, this is how it should feel. And I think by giving it to the team, you start to make them feel not only more in control, but you make them feel more responsible, right?
Yeah, sure. And what do you think about all the explanations on some of the things that's helpful when Komodor explains why we did that check, why it's important? I think it's useful, just not...
Yeah, no, I absolutely do. And I apologize on my other stream, I'm not sharing your lovely face. So let me put your lovely face through. There we go. So people can see you now.
I feel a bit under the rest.
You're fine, because otherwise it's me on YouTube talking to myself like some sort of maniacal weirdo. So look, I think...
You won't be the only one.
Okay, well here's the thing, like the checks are useful. Some people will look at those, I can't stress this enough, some people look at those and think, oh, I don't need that. I know about Kubernetes, I know about the workloads. But you're not thinking with the broader scale of there are companies who will literally spend tens of thousands of dollars getting someone to create a Git repository with a README that says, if your service does this, do this. You know, it's happened, I've been there. And if you don't have to do that and you can auto-generate these kind of like triaging options, it's super useful. I mean, again, think about where you want to take Komodor in 5 years' time. I want to see who ran those. I want to see if they clicked on that and they said, yes, I've done these activities, because that is a level of provenance and auditing of them saying, I swear that I clicked this button, I checked to see if the service restarted, but it didn't. And now we're getting into the dynamics of actually understanding how our team are operating, which is interesting, right?
Yeah, I think there was a statistic I stumbled upon recently about how many unaudited changes are going on average in a cluster. I don't remember the exact number, but it was something ridiculously high. And I think for an SRE or a platform engineer, it's a bit scary to know that so many hands are touching your system and making changes that you're unaware of, and you can't even assign blame. You send the screenshot and send it over.
I think that's super true. It is the strongest part of that message that, as I said earlier on, is about. I think Kubernetes is now like Linux. It's no longer just kernel engineers and system engineers and coders of the OS. It is now people actually like as users. So Kubernetes effectively has users who just want to use it to do a thing, and those users also need to know a bit of information about why the thing isn't working. They don't need to be an expert at the underlying operating system. And as we can build platforms like Komodor to start to create filters and knowledge filters, that's super useful, because filtering the data that's coming out of these systems is work that is worth doing, because as I said earlier, things will exponentially increase. It'll only get more and more. You'll find that there'll be people deploying ephemeral K8s clusters that are immutable, that have a 1 minute stand up and spin down time, and they're using those just to scale out. You won't be scaling out by pod, you'll be scaling out by cluster dynamically. And so can you even imagine the amount of events and debugging and how difficult that would be? So with the events timeline and stuff like that, you can start to build a picture. So I think, yes, absolutely, it's kind of a trend that's only going to get more pronounced.
And I was going to ask you, when you took that screenshot, it said, I'm not getting paid.
Oh, yeah.
I've never been an SRE, I've never had to deal with that kind of situation. Is that something that happens a lot when you want to assign blame?
Do you know what? I mean, if there's product requests or features here, one of the things I would say is that actually looking at having time frames between things, right? Because if Amex, for example, you could catalog how long you spent on a call, and that would factor in into your pay, and other places as well. Like to say, I spent 8 hours on this availability issue for this team, and it was fixed here and here. Here's the attestation. I can say that and screenshot that and send it to my manager. That has value. But also, from a quantitative perspective to look at how many availability issues are we having a month. This comes back to the SLO story. SREs are closely following those service level objectives, which are part of the SLA, part of the agreement with your customer, and to be able to say, look, it tells us we've had 1 minute of availability issues, which is within our P99, within our 4 nines. That's great, right?
Yeah. Anything else you would like to say, Alex?
No, not at all. I would just like to thank you for having me for my ramblings. And if anybody would like to play with the stuff that I built, please go ahead and on Twitter, just DM me if there's anything broken or open an issue. But check out Komodor, check out the way that I've built this stuff. It's quite representative of it's very close to a way that we were deploying it of another very large company I worked at for a time.
And I just want to add that Komodor has a 2-week free trial, and you can do the self-serve installation yourself. Just go on the website komodor.com, you can install it and follow Alex's video. We're going to share the recording with everyone, and you can try out Komodor for yourself. You can also check out our open source tool, validcube.com, and join our newly minted Slack community. And that's it. Thanks everyone for joining, and thank you, Alex, for leading this workshop and
you're very welcome.
Showing Komodor the way only we can. So
of course.
Till next time.
Thanks everyone. Ciao.